All right, folks, looks like everyone's filling in. Thanks for joining this session. First and foremost, I wanted to introduce you guys to my session. My name is Jonathan Brito, product manager here at Databricks. I cover Lakehouse storage. So for today's session, we're going to cover a handful of topics. In particular, we're going to cover a challenge that I see a lot of customers hitting these days as they try to adopt an open lakehouse, and that's choosing an Iceberg catalog. What we'll do in this session is cover three things. First, how to choose an Iceberg catalog. We'll look at what factors are really important to customers. And then second, we'll actually introduce managed and foreign Iceberg tables. So if you saw the keynote today, these are some of the latest features that are hitting public preview in terms of our Iceberg support that we're offering here at Databricks. And then lastly, throughout all of the presentation, we'll be comparing popular Iceberg catalogs. So you'll see a sprinkle of Unity catalog as well as other catalogs and see how they stack up against our criteria for what we think it makes a great Iceberg catalog. So to kick things off and to tell our story, we're starting with a protagonist, that being Angela. Angela's a platform architect, and her organization is actually migrating to an open data lakehouse. And Angela here has been tasked with leading that migration and making the right architectural decisions to set up her organization for a future-proof architecture. Wow. Okay, great. So what's her company? Her company's called Dunder Mifflin. A few laughs in the audience. And our company, over the years, has been trying to solve a variety of different use cases, and as a result, they've introduced a handful of different commercial and open source engines to their architecture. So they have some Databricks, you have some Snowflake, you have some Kafka, and as part of their migration to an open data lakehouse, they actually, last year, spent a whole host of time looking at different formats they wanted to standardize on. And after careful deliberation, they decided that Iceberg would be the direction they wanted to go in. So now it's up to Angela to make everything work. So this should be really easy, says Angela. She looks at the Iceberg ecosystem, and as you can see here, there's a whole host of connectors for Iceberg. It has a really expansive ecosystem. So what could be difficult here? It's not quite that easy. And the is because Angela needs to choose an Iceberg catalog. For those who are new to Iceberg, the Iceberg catalog is the top-level part of the table architecture. And it actually has a lot of important tasks that it's responsible for. Your Iceberg catalog you use for things like creating tables, changing the name of a table, dropping tables. But most importantly, it actually tracks the current metadata for a table. So all reads and writes to an Iceberg table actually have to go through the Iceberg catalog. So the Iceberg catalog itself introduces a whole host of interoperability challenges if you don't make the right decision. So there's a lot of options on the market today that Angela can choose from. So let's help Angela look at a few options to start. So let's look at Snowflake Horizon Catalog. Snowflake Horizon Catalog obviously has great interoperability with Snowflake itself. You can read and write from Snowflake's engine. And also, Snowflake Horizon Catalog can also federate to other Iceberg catalogs, particularly, say, Glue and Iceberg REST catalogs like Unity Catalog, which provide interoperability with, say, Athena or with Databricks. However, one big gap is that Snowflake Horizon Catalog doesn't actually allow for writes from external engines. So if you're trying to use different open source engines, say Flink or Kafka here at the bottom of the page, you're actually going to get stuck. In certain cases, all you really have is read interoperability with Snowflake Horizon Catalog. All right, let's try Polaris, another Iceberg catalog that's out there. Very similarly, a lot of interoperability with Snowflake. So with Polaris, you can federate in Snowflake Horizon, you can mirror tables from Snowflake Horizon Catalog to Polaris and federate them back into Snowflake to get full bidirectional interoperability. As an Iceberg REST catalog, you actually have reads and writes from a lot of the open source engines that you see at the bottom of the page. However, that's really where interoperability ends, in that Polaris doesn't really offer the same level of interoperability with other catalogs it does with Snowflake Horizon Catalog. And as a result, you have a whole bunch of silos that you're seeing here on the page with BigQuery and, say, Athena and Redshift. All right, so this is a lot harder than we thought. We started with a really great picture with all different Iceberg connectors, and now we have a bit of a shrunken ecosystem. So for Angela, what should she be looking for when she chooses an Iceberg catalog? So the first most important thing she should be looking at is fully open, that catalog is fully open for external writes and reads. And this is really important because it provides the ability to choose whatever engine you want to use for the workload. This is kind of the dream of a lakehouse. It also provides a lot of interoperability in terms of future-proofing your architecture. So if tomorrow you want to, say, switch from one engine to the other, you can easily swap back and forth. Second most important piece of an Iceberg catalog is going to be advanced table optimizations. So the Iceberg catalog, not only does it manage your reads and writes to the table, it's also going to manage your optimizations. So ultimately, the data layout and what sort of query performance, as well as storage efficiency you get, is going to be driven by what catalog you choose. And of course, you can do a lot of this work manually, but that can be really difficult to do. For folks who have tried to optimize Iceberg tables, if you're using partitioning, you have to choose the right partition columns. If you're running compaction, figure out when exactly you want to run compaction to make sure you're getting the best bang for your buck. So there's a lot of things that go into this, and if it's not automated, it's a lot of time-consuming effort from your team that you can be running into. Lastly, is interoperability with external catalogs. So this is particularly important in just how the ecosystem has evolved over time. Well, what we've seen is that a lot of different platforms actually require using their catalog. So for instance, if I want to write with Athena, I need to use Glue Catalog. This results in architectures in which you have usually multiple catalogs at play. So having the ability to interoperate across catalogs becomes really important because it not only gives you the opportunity to choose the right engine that you want to use for your workload, but it also provides a single unified view of all your data. Because if you can federate from different catalogs and bring all that data into one, you can kind of create a catalog of catalogs, which is really good for data discovery as well as for governance. Okay, we have our criteria. Let's go back to the drawing board and let's look at Unity Catalog. So, you've heard a lot about this in the keynote, but Unity Catalog is introducing two new features that are critical to meeting all these requirements. First is managed Iceberg tables. You can think of these as tables that are created within Unity Catalog. Unity Catalog is going to manage the reads and writes as well as the table optimizations. These tables are fully integrated with the Databricks platform and are fully open via open APIs. The second feature that's going to public preview are foreign Iceberg tables. So foreign Iceberg tables are basically the contrast to managed Iceberg tables. These are tables in which an external catalog, so say HMS or Glue or Snowflake Horizon, is the catalog that owns that table, that manages those reads and writes. These tables are going to be read-only within Databricks, but we'll still have access to all the different governance features that you have within Unity Catalog. All right, so let's deep dive into each one of these features. So introducing managed Iceberg tables. As I mentioned, managed Iceberg tables are fully open to the Iceberg ecosystem. You can write and read from these tables from Databricks, as well as from any external Iceberg engine. And the way that we get interoperability with the Iceberg ecosystem is through the Iceberg REST Catalog API. So for those who aren't familiar, the REST Catalog is an open API spec that exists in the Iceberg community for interacting with Iceberg tables. It basically decouples the catalog backend from the client. So it provides a really nice unified experience, regardless of which engine you want to connect to whatever backend. Unity Catalog was actually an early adopter of the Iceberg REST Catalog. We actually launched read support for the Iceberg REST Catalog back in 2023. These new features are basically implementing the write side of those APIs. So through these write APIs, you virtually get compatibility with almost any engine that you want to use in the Iceberg ecosystem. So think the Apache Spark, Trino, Flink, et cetera. All right, so let's consider an example, and in particular try to determine why this is so important and why this becomes really key for customers. So going back to Angela, suppose if Angela wanted to write from Snowflake. Sets up Snowflake Horizon Catalog, writes it using Snowflake Engine. But then tomorrow, her business needs change. And she decided, hey, I actually want to migrate away from Snowflake Engine and use open source Spark. So the trick with this is, can she actually do this migration? How easy or how hard would it actually be? It actually is a lot harder than you think. And the reason is because open source Spark cannot write to the same table as that Snowflake is writing to, it not only is a migration of the engine, it's also a migration of the catalog. So for her to get open access with open source Spark, she needs to change from Snowflake Horizon catalog to a whole different catalog, which if you don't have the proper tooling, this can introduce a lot more work to the migration. This is recreating new policies in your other catalog. This is potentially redirecting downstream workloads. A whole host of things that may not necessarily have been part of her original plan in terms of the migration. Okay. Now let's see if we started out with this exact same example, but let's swap out Snowflake. Let's start instead with Databricks and Unity Catalog. So in this case, you have Databricks writing to table 1 using UC. And the nice thing about this approach is that it becomes really easy to swap in Databricks for, say, open source Spark as needed. And the reason is because they can write to the same table. So this basically gives you the benefits of having no vendor lock-in, all from Unity Catalog. Cool. So the fact that now you can write Iceberg with Databricks, it actually unlocks Databricks' industry-leading performance for ETL on Iceberg workloads. So what you're seeing here is actually a benchmark that compares Databricks SQL to Snowflake's Gen 2 warehouses. And it just compares your ETL TCO as your data scales. And as you're seeing from left to right on this slide, Databricks does a really great job of efficiently managing your costs as your data grows and grows in size. While in the case of Snowflake, it actually grows exponentially, where at scale, you're looking at about a 15x difference in terms of your ETL costs. So for folks who are planning to standardize on Iceberg, this is a huge boon in terms of being able to benefit from these TCO savings. All right, now our second criteria was advanced table optimizations. Let's look at how Unity Catalog stacks up. So Unity Catalog actually offers a whole host of automated optimizations through a feature called predictive optimization. So predictive optimization takes a lot of the toil of managing your tables out of the hands of your team to unlock you to do different, more high-value activities. What predictive optimization does is actually does this really intelligently. So it analyzes your query patterns and determines the best tables to actually optimize to make sure you're maximizing your ROI. Your managed Iceberg tables also can leverage liquid clustering. So for folks who are less familiar, liquid clustering basically replaces partitioning and z-ordering, where instead of having to go out and choose your different partition columns, liquid clustering will allow you to change your clustering keys without actually rewriting your data. So ultimately speaking, you get incremental clustering that is automated by predictive optimization. As you're seeing here, quite the benefit in terms of the performance. Okay. And one nice thing about all of this is that these optimizations are actually open to any engine that you plan to use. They're actually open to any engine that you plan to use. So if you're tomorrow decide, hey, I actually don't want to use Databricks, and I'm optimizing these tables with liquid clustering, any engine that's reading these tables would still benefit. So for instance, in the case of liquid clustering, one of the reasons why this works is because with liquid clustering, you're actually optimizing the Parquet files themselves. All those optimizations are then reflected in your Iceberg metadata. So any engine that can speak Iceberg, when they go in to read these tables, will benefit from these optimizations. Let me fix one thing really quickly. Okay, sorry about that. All right. And our last criteria was interoperability with other Iceberg catalogs. So the way that Unity Catalog solves this problem is through Lakehouse Federation. So how does Lakehouse Federation work? There's really two ways that we connect to external data sources with Lakehouse Federation. First is database federation. So with database federation, you're connecting to databases that you're seeing on the bottom left-hand side of this page. And what you're doing there is that when you run a query within Databricks, it actually pushes the query down to that external database to run the query. Ultimately speaking, this is really useful if you're trying to access data in place when that data is stored in a proprietary format. The other way that Lakehouse Federation works is through what we call catalog federation. This is a bit different and contrasting to database federation, where with catalog federation, what you're actually doing is going directly to object store to read these tables. So this is great if you're storing your data in an open table format like Iceberg. Because ultimately speaking, you actually can have a lot more performant queries and a lot more cost savings, because when you run that query using catalog federation, it's only using Databricks compute. Rather than in the case of database federation, you need both engines at play. And your Iceberg tables are all now accessible using catalog federation. And the nice thing about that is once your Iceberg tables have been registered within Unity Catalog, you can, even though they're not managed by UC, you can still leverage all of UC's advanced features. Things like fine-grained access controls, lineage, auditing, all on these tables. Cool. So how does this all work? So you're seeing in this diagram an example of how to register a foreign catalog within UC. And the first step is ultimately creating a connection. So this is creating a connection object that links Unity Catalog to your foreign catalog. Today, we support HMS, Glue, and Snowflake Horizon for this sort of catalog federation approach. From there, you do what's called creating a foreign catalog within UC. This is basically mounting that foreign catalog within Unity Catalog. So if you were to look, say, for instance, in your Catalog Explorer, you would see your UC Metastore, and then underneath that, you'd have your foreign catalog listed out. And then underneath that, you see all your schemas and all your tables. And this works across those Iceberg tables. This covers actually all your tables that you could have. Delta tables, Parquet, CSV, et cetera. Everything becomes unified in UC. Another great benefit of this approach is that ultimately speaking, when you read the table, you're guaranteed freshness. So in the case of an Iceberg table, what's actually happening at query time is that UC will ping the other catalog for the pointer to the latest Iceberg metadata JSON file. From there, it has basically everything it needs to run the query directly against object storage. So you're guaranteed freshness, and all that is done automatically behind the scenes by UC. And in this case, you can see here that all of your existing workloads remain uninterrupted. So this is a great actual first step if you're trying to eventually migrate your tables to UC. This can allow you to migrate readers over to UC before you actually migrate over writers as well. Okay, back to Angela. Now we're going to look at how we can use federation again to solve another common interoperability challenge I see with customers, which is you have customers who are using Snowflake and they're using Databricks, and they want to write from both those engines, but then make everything accessible to both engines. So write from both, read everything from everywhere. So to do that, you can use federation. From Databricks to Snowflake, you can use Lakehouse Federation to register a Snowflake Horizon catalog within UC. Once you create external locations for all the Iceberg tables that are in your federated catalog, UC will know to go to object storage to read those tables. In the reverse direction, Snowflake actually offers what they call a catalog integration. It works very similar to Lakehouse Federation, and that ultimately what you're doing is you're registering Unity Catalog within Snowflake as an external catalog. From there, you can query these tables within Snowflake. And what's nice about this architecture is it's very flexible. So if ultimately tomorrow you said, hey, I want to use an open source Iceberg engine, as we talked about earlier, you actually do have support for the Iceberg REST catalog within UC. So you could just connect, say in this case, Trino to Unity Catalog's Iceberg REST Catalog API to write or read to UC. And beyond that, all the tables that we've federated from Snowflake Horizon Catalog are available in UC. So Trino can actually read your Snowflake managed Iceberg tables from Unity Catalog. And again, that's all with unified governance. But things could be even simpler. Last week at Snowflake Summit, Snowflake actually announced that they'd be adding support for writing to external Iceberg REST catalogs, of which Unity Catalog is one. And with now the fact that we have support for writes to Unity Catalog, Snowflake in this case could actually just write directly to UC. So creating a UC managed Iceberg table from Snowflake. So your architecture becomes a lot simpler and a lot fewer hops. Okay, so let's go to a demo. What I'm going to do here is show you guys a notebook in terms of how to use manage Iceberg tables. Creating a managed Iceberg table is incredibly easy. This is a notebook in Databricks, and I've already have a bunch of things set up. As you can see here, the way to create a managed Iceberg table in Databricks is really just to append this using Iceberg to your create statement. So if I run this, this will take a second to run. As you can see here, what this notebook is trying to do is actually, it's tracking user impressions for our company, Dunder Mifflin. So we have two columns, the user profile, which is going to be different users that are actually interacting on the website, and then the actual impressions that are hitting that website. Okay, looks like that's done. I can then from there insert data into my table. This is an example, just some dummy data I put together that shows a dummy user, Alice, and a lot of impressions that she's making to the website. And then you can query the table within Databricks. Okay, cool. And then you can see the result here. So if you're paying close attention, you can see here that I'm actually storing a JSON as actually a string. And this actually isn't really great. For a lot of folks who are laughing in the audience, if you try to query this, particularly querying individual elements in that JSON, your query performance can really suffer. Alternatively, if I wanted to, I could potentially flatten out this table and basically fan out a whole bunch of different columns. That would improve my query performance, but then I'll end up with a bunch of empty rows and columns in my table. So that's not great either. Iceberg actually has a solution for this, which they're bringing, which actually just got adopted by the Iceberg community and Iceberg v3, and it's variant data type. So we're actually going to have a private preview for Iceberg v3, including variant data type, next month. And in this demo, I'm actually going to show you how it works. So how we can do this is, if I scroll down and then open up this. So you can see here, I'm going to create a new table using Iceberg v3, version 3 within Databricks, and then I'll see tasks from the original table, but in this time I'm actually going to parse the JSON so I can store this string as a variant data type. Just let that run for a second. Cool, looks like that worked. And then if I try to query the table, you'll see here now that it's stored as a variant data type. So now this is an object rather than a string. And this has a lot of great performance benefits because if I decided, hey, I actually want to just query, say, the user ID element, I could run this query, and you can see in less than a second, I got that result. So I'll be coming to private preview in July. So definitely check out that and reach out to your account rep if you want to get part of that private preview. Let me switch back to my presentation. Okay, cool. All right. Now bringing everything together. This slide here is comparing Unity Catalog to other popular Iceberg catalogs across the metrics that we were discussing throughout all of this presentation. So external access, being able to read and write from external engines, table optimizations, There's a variety of different optimizations that exist in the Iceberg community. Storage optimizations like snapshot expiration or file cleanup, file compaction, familiar, I imagine, with most folks, and then obviously clustering, and then the federation of external catalogs. And as you can see here, Unity Catalog is checking all those boxes for Angela, while the other catalogs that we have pictured here have limitations that you need to consider. Also, one important thing to note here is that these Iceberg tables are going to be adding a lot of great functionality that is popular within the open source Iceberg community. In particular, adding support for things like hidden partitioning and partition evolution. So we actually do this in a really creative way, in which it actually allows you to use liquid clustering from an external Iceberg engine. So what that means is, if you open up the Iceberg REST catalog and you're using an external Iceberg engine, if you create a table with a partition column, we actually interpret that partition column as a clustering key. So then under the hood, you can actually use liquid clustering from outside of Databricks with an Iceberg engine. And then you can use partition evolution to actually evolve those, to change those clustering keys. Because every time you change a partition using the Iceberg REST catalog, we'll translate that into changes to clustering keys. So this really unlocks liquid clustering for, again, the entire Iceberg ecosystem. And then lastly, with Iceberg v3, you just saw the demo a second ago. These are some of the features that will be coming to manage Iceberg tables and as part of this private preview. In particular, deletion vectors, which for those who aren't familiar, this is bringing sort of merge on read semantic to tables. This really can greatly improve your write performance. Row IDs, these are really important for incremental processing. In particular, with row IDs and deletion vectors, you actually can unlock row-level concurrency. So that's one thing we'll be bringing to these managed Iceberg tables as well as part of this preview. Because through that, you actually can reduce the chances of having conflicts as you're writing to your various managed Iceberg tables. Variant, we talked already a bit about in terms of the advantages you get from that in terms of processing semi-structured data. And then write defaults is another great feature that I'd be bringing to these tables. So it's been a long journey. We have had these features in private preview, and these are some actually the most well-adopted private preview features that we've had here at Databricks. So it's been really fun leading the team to bring these features to public preview. And as I mentioned, managed Iceberg tables and foreign Iceberg tables are fully available now for public preview. So check out the documentation to start testing. And beyond Databricks, we actually did a lot of work leading into this launch to get a lot of various partners involved, particularly folks trying to land Iceberg tables with Unity Catalog. So here featured is a quote from Red Panda, who actually launched an integration as well with our Unity Catalog Iceberg managed tables, which allows you to basically take data from Kafka topics and land them directly into Unity Catalog managed Iceberg tables. And these optimizations benefit from these tables benefit from all the optimizations I discussed earlier. So you'll have liquid clustering on these tables. So it's a really great win for really customers across the board. Cool. And then closing things out in terms of the full picture, this kind of brings everything together. So as you can see here, the Unity Catalog really provides a unified governance solution for really everything you can have in a lakehouse. So starting at the storage layer, we obviously have support for Delta Lake. With these announcements, you have full support for Iceberg as well in Unity Catalog, as well as any of the legacy formats you may have in a lakehouse. For a lot of folks, we see they still have some Parquet, they still have some CSV tables, JSON, Avro. All that is supported within Unity Catalog. Moving a layer up, we go a lot further than just the tables within Unity Catalog. It's a really unified governance solution for everything in a lakehouse. So you have AI models, files, notebooks, dashboards. All of that can be governed by Unity Catalog. In terms of features, we don't just stop at the traditional access controls and auditing. Unity Catalog actually provides a lot of other features, advanced features that you can bring to these various tables. So lineage, cost controls, quality monitoring, and this is all accessible to really any engine that you want to use in the Lakehouse through the Unity REST or Iceberg REST APIs, as well as with any external catalog through federation. So that's my talk. All right, thank you, folks.